Yesterday, I did a video on how Huawei had issued the groundbreaking news to its largest tech firms to stop buying Nvidia's H20 and the RTX Pro 6000D. This was pretty shocking, but not totally unexpected. However, in the discussion, we said that Beijing must feel very confident, right? If they were going to make a move this big. Understand that right now, even more important than the chips themselves are the AI models and the AI agents. The race for agency is on and is of the utmost importance. So there's no way that Beijing would go ahead and do something so drastic if they weren't 100% sure that they could rely on their internal compute power. And of course, today we see why they were so confident. We have Huawei Connect kicking off in Shanghai, and there were some absolutely crazy announcements. So first, I want to welcome you to Rubin Tech, where we talk about the intersection of tech, politics, and finance. I'm not going to cover everything at Huawei Connect because obviously you'd be here for quite some time, but I do want to cover a few things, what I believe to be the biggest highlights right now, and then I'll release some videos that cover some other aspects too. Now, the big thing that came up that I thought was very interesting, and this is just a picture. Unfortunately, on the Huawei Connect site, I couldn't find this nice image, but someone wrote it up on X. Is basically they released their Ascend AI chip roadmap. Now, their Ascend chips, as we know, are their accelerators for AI. And right now they're on the 910C. And what they're saying is that in 2026 Q1, they're going to release the Ascend 950 PR. After that, 2026 Q4 is the Ascend 950 DT. And then we can see it goes from the Ascend 960 all the way up to 970. And what's happening here is that as a single chip, 950, the Ascend 950 is supposed to be on par with Hopper. Okay. Remember that Hopper would essentially be 2 generations of Nvidia ago. This is on a chip by chip basis. Take that with a grain of salt, because you might be saying, wait a second, why would why would she and Beijing be so confident if they're 2 generations behind? Just listen, let me get to this in a second. I will explain everything. And then as the post says here, the 970, the 960 will be on par with Blackwell. And then the 970 is targeting Rubin plus performance. Okay. So as I've stated on this channel many times before, Huawei and China is probably 1.5 generations, maybe 2 generations behind on a chip by chip basis. However, what matters is the fact that Huawei has learned, and we saw this with the CM384, the Cloud Matrix 384 this year, on how to build the interconnect between more of these chips and build it better and faster. So even though on a chip by chip basis, they can't compete with Nvidia, where they do beat them is by loading tons of these chips up. And so Huawei introduced what they called their super pod. And they basically, again, they're using just brute force via a larger super node that connects 8,950 Ascend accelerators and 15,960 Ascend accelerators together. Okay, this is a full order of magnitude, almost 2 orders of magnitude larger than the CM384 for the 960s. Right, so the CM384 connected 384 910C accelerators, and now they're talking about in their next super pod having 8,950s and 15,960s. To give you an idea of how large this is compared to what's out there right now, NVIDIA's best offering for what you would call a comparable offering is the NVL72, which is 72 Blackwell chips. And with Vera Rubin, they're going to have an NVL144. So with the NVL144, they only feel confident in a SuperPod hooking up 144 of them. And Huawei is saying that we're going to beat that by 2 orders of magnitude with the 960. Okay, the end performance surely crushes NVIDIA's coming Vera Rubin single rack. I believe Huawei said that based on what they see from Vera Rubin, that they're going to beat Vera Rubin by 6x. Okay. On a system. Remember, this isn't the chip. This is the system. Okay. And so here they have their SuperPod roadmap up for us. We can see what's called the Atlas 950 SuperPod coming out in 2026 Q4. This again is the 8000 Ascend 950s DTs. The accelerator cards are, you could call them chips or you can call them GPUs, whatever you want to. Total memory capacity of 1,152 terabytes and compute power, FP8 and FP4. This should be of note because remember that the 910C accelerators couldn't do anything below a FP16. So this is also a big improvement in these new Ascend chips. Okay, and 8 EFLOPS and 16 EFLOPS. And so over here we have Atlas 960 SuperPod, Ascend 960, 15,488 chips. 4,460 terabytes of memory and 30 EFLOPS to 60 EFLOPS. And then right here, they have 1.2 EFLOPS to 3.6 EFLOPS. So you might say this is 30x the performance. Huawei and their note, I did see this. Maybe I should have brought it up. They said 6x. I think they're actually targeting per watt because, of course, having more of these accelerators hooked up, they're going to have a higher energy usage. And as so many chips are under the scale up domain, the reliability is better than linking multiple racks together. Huawei claims to achieve 95% efficiency on an 8K SuperPod versus Nvidia's 3,584 card SuperPod. Okay, so what's happening here is that Nvidia has to hook these NVL72 racks up together, and Huawei has much better interconnect, right? And you would expect this because Huawei is a networking company. Before they were forced by the US government and our ridiculous sanctions to be an everything company, right? So actually China right now, I'm in America, you should thank America. You should thank Trump, the great builder, for giving you the kick in the butt you needed to build this incredible powerhouse, right? So I say that facetiously, but I have heard many times, I've seen on YouTube many times that Trump is referred to as the great builder in China because of how China has responded to these tariffs, how they have responded to these export controls, how they have responded to these sanctions. So anyways, because of Huawei's superior ability to interconnect these using their light system compared to what Nvidia is using, which is just basically copper, they have a 95% efficiency over the Atlas 960 Supercluster. He goes on here. It doesn't stop here. Obviously, you can connect these superpods to form a large cluster. 950 Supercluster will have 520,000 chips connected together, while 960 Supercluster has over 1 million. These are mind-boggling numbers, okay? These are mind-boggling numbers, and if this pans out, if this is true, which I don't think Huawei would go on stage, I don't think that Beijing would have made the statement yesterday that they made if they did not believe this, okay? So understand, everything in life has to be taken with a grain of salt, but what Beijing did by telling their top companies, hey, we're not buying Nvidia anymore, is they're saying we have to be self-reliant. Absolutely, we cannot depend on these maniacs with the orange clown in charge overseas. We have to do it ourselves, okay? And they wouldn't do that if they didn't truly feel that they could do that. That's my opinion. Maybe you feel different, but I am certain that, if these numbers hold out, okay? Because this is mind-boggling. 520,000 chips. Like, you can connect that many chips, but not in a SuperPod, okay? Not with what they're talking about for the kind of interconnectivity levels you would expect from a SuperPod, okay? So, this is we've never seen this kind of scale before, okay? The NFPA compute will reach 524 exafloppers and 2.2 zetaflops, respectively. This is moving up into the quantum realm of like how many, how much information is there in like a molecule? We're really not in one singular molecule. That wouldn't be that high, but like in an object. Okay. We're really getting pretty far up there. Numbers aside, how far is it ahead or behind Nvidia on single die PPAC perspective? It seems 950 DT for decoding and training will be quite close to Hopper and Blackwell. On memory front, by using a custom HBM standard, while Nvidia only customized the base die of HBM4, Huawei is ahead, but sources of DRAM, Swasher is slightly behind in DRAM die. This is absolutely going to be correct. And Huawei has actually mentioned that themselves. They've mentioned that this summer, that even their HBM solution will not be up to par with what you can get from Samsung. But of course, this is a first step. Okay. And the fact that they came out with this so soon is absolutely amazing. And this is something else that they released, but I'm not going to cover it today just because we have so much to cover. In terms of networking, Huawei is massively ahead of Nvidia thanks to Huawei's years of networking know-how and advanced vertical integration across all layers of optical networking. I've covered that many times on this channel. And most importantly, new Ascend chips now support SIMT to improve CUDA compatibility. Okay, so this is something that they've been looking forward is to have an intercompatibility layer, especially what happened with the last the issues with DeepSeek training their second version model. Where on DeepSeek R1, they actually had some very low level CUDA code in there. And when I say CUDA, I'm referring to the CUDA ecosystem, not CUDA C++. And this code was not portable at all, and they weren't really able to get that initially on a 910C accelerators, but now they are actually making compatibility layers to address this issue. All things considered, Huawei is now possibly the biggest contender to Nvidia and merchant AI chips. Why does he say this? Because on this channel, again, I have told you, and I am going to bring this up, there is a difference between merchant AI chips that are available to actually buy and to install in your own in-house, versus what's available on the market. Right now on the market, Google Alphabet actually has the best chips, okay? It's called, for inferencing, I'm forgetting the name. It's called Ironwood. And then Trillium would be their training one. So they actually have separated the two things. They have a specific training chip under Trillium, and they have a specific inferencing chip under Ironwood. But you cannot buy those directly. And Google, even if they did say, hey, we're going to sell these, they'd never be able to scale up to what Huawei and what Nvidia can. So really what this guy's saying is in merchant chips, it's Huawei and Nvidia, right? Its 8K plus networking tech has been in testing for more than a year, and with IDUV solved, it's a matter of time when large frontier models will be trained on Ascend chips. This has been all over the news, is that China right now, in China, they are testing finally IDUV, their own 100% own in-house developed tech. Okay, they'll be using multi-layer patterning, but these machines, from everything we heard, they're not built off of anything from ASML. Understand they had DUV machines left over from ASML. Unfortunately, ASML, even though they wanted to, they were unable to service them thanks to US sanctions. There you go, Netherlands. That's what you get for kowtowing to the US, right? You have a company that lost billions of dollars in sales, billions of dollars in service contracts, all because of Donald Trump, right? He's the king of your world. I mean, it's just nuts, right? Can you imagine running ASML and you have a customer willing to spend billions of dollars with you and you can't do it? And it's because of a guy that's not even in your country. It'd be the weirdest thing. It's a matter of time when large frontier models will be trained on Ascend chips. A matter of time, I would imagine that they're going to start being trained immediately. So this is literally groundbreaking news. I don't think we can say anything besides that. Now, what I want to do here is, this is the keynote speech by Eric Su at Huawei Connect. And he discusses the groundbreaking SuperPod interconnect, leading a new paradigm for AI infrastructure. And I'm not going to go through all this. This is very long. This is technical. I will leave a link up to it because it's actually a very good read too, if you got the time. But I know a lot of you aren't too tech savvy, and it actually is pretty deep in the later parts. I do want to discuss though here, I want to be crystal clear, okay? And Eric actually, I think he says it in here. Yes, he does. He's going to say what I'm going to tell you here. And what I've said on this channel, on a chip-by-chip basis, Huawei China has acknowledged, Ren Zhengfei, they have all acknowledged that they are going to be behind the US when you look silicon to silicon. And that is because that when the world and our standards were more open, prior to the chip war that the US initiated, when all of a sudden, out of nowhere, we blindsided China and said, okay, we're going to try to crush your greatest companies. We're going to take away this technology from you. China was fine using EUV and DUV technology from ASML and trusting us for like ARM for specs for the chips, and everything like that. They were fine using that. And so when all that stuff just got yanked from them out of nowhere, they had to go on a road to self-dependency. And that takes time. It absolutely takes time. Okay. But what they had, one is they have a lot of brilliant people and they have a lot of determination. Okay. But the other thing they have is that Huawei was a networking powerhouse. Okay. So before all this happened and before, Huawei made some great Android phones back in the day, But what they really were known for was their 4G and 5G technology. They had been in networking for years. That's kind of what they built their chops on. And that's where the CM3A4 first came out. And it, even though the 910C accelerators weren't even comparable to Hopper, the CM3A4 could brute force past the NVL72. And the reason that it did that is because they connected 384 of them, and they had such high speed and low latency interconnect speeds. Okay. And the technology behind that is the LTPO, I think it's called, off the top of my head. I might have that wrong right now. But they basically use light, again, where Nvidia uses copper. Okay, so they were able to hook up 384 of these in one unit and have them communicate incredibly fast, as if it's essentially a single chip. I mean, really, that's what you're talking about. And if you don't believe me, look at Jensen Huang. Jensen Huang will say this in his keynote. He said it for the NVL72 and NVL144, that at those speeds, that when you hook up 144 of these Vera Rubins, or you hook up 72 of these NVL Blackwell chips, at the type of interconnect speeds that they have even on those systems from Nvidia, which is not as fast as what Huawei has, that essentially it acts as a single die. It's that quick, right? It's literally that quick. I mean, is it as quick as that? No, obviously it has to travel, and light takes time to travel, or electrical signal, but it's right there. It's literally right there. Okay. And so Huawei is able to achieve that with 4x amount of chips with the CM3A4, or actually that would be 5x amount of chips, right? 5 times 72 is 350, 384. Yeah, 5x plus. Okay. And now what we're seeing is, of course, the way they're going about it. They're behind on silicone, but they have networking. They are the premier networking company in the entire world, period. Nobody holds a candle to them. Okay. And that's where they're going to beat us. They're going to beat Nvidia by hooking more of these up. And right away, all the people are going to be coming into the comments like they did with the CM3A4. Yes, these are going to use more power, but I'm going to tell you something right now, and I will do some videos on this. Okay. I haven't done this yet. I've said I have. Been busy. I promise I will get this out. For those of you in America that don't understand this, China is the world leader in energy production, and it's not even close. China installed more clean energy last year, more green energy, than the rest of the world did combined. Okay? China, on its own, installed more clean energy than the rest of the world combined. Okay? And yes, I know they still have dirty energy out there. Everybody does. Okay? But I'm just telling you, they are securing all aspects of energy production. And really, I want to tell you something right now. I think that looking at economies by GDP is wrong. I think it's wrong. I think we need to go to the Kardashev scale. We really do. Where when you look at a civilization, it's by energy production, because that's what's matter. Energy in, production out. As long as energy costs are low, your production, all your means of production, no matter what you're making, and now it's AI too. Okay, it's even more important. But if you have cheap energy, cheap available energy, all your production is increased and it costs less. Okay, and China produces way more energy than America does. I don't have the exact figure up for me right now, but I can tell you that it's not even close. I believe it's at least 2x the size of America. I would say at least 2x the size of America. I will find that out for you later. Okay, let's go ahead and let's get to the article here. I just want to show you some things from Eric Zhu. Ladies and gentlemen, good morning and welcome to Huawei Connect 2025. It's great to see you here in Shanghai. I would have loved to gone to something like this, but I mean, can Americans go to this? It's like, I don't know, with these sanctions, it's so weird, especially with, the crackdown right now, Trump cracking down on everything, free speech here. The past year has been a memorable year for all of us, especially those of us who work in AI or take a special interest in it. The surprise debut of DeepSeek R1, the DeepSeek moment, right, where inferencing was brought into training back in January, gave us all a taste for AI during the Chinese Spring Festival. Many model training specialists have pulled all-nighters working to adjust their training methods and reproduce the DeepSeek results. At Huawei, it was a complete paradigm shift. I've talked about that many times, but if you didn't know, in training before, they never used inferencing. They're like, oh my God, inferencing takes training to the next level, and it does it cheaper. At Huawei, and you can also call it chain of thought. At Huawei, we have felt the impact too. Between DeepSeek R1's launch in January and April 30th, our team worked closely to make sure that the inference capabilities of our Ascend 910B and 910C chips can keep up with customer needs. Before we begin, I'd like to revisit the 5 key points I discussed at last year's Huawei Connect. Sustainable computing power is the cornerstone of continuous advancements in AI. Absolutely. The Chinese mainland will lag behind the semiconductor manufacturing process nodes for a relatively long time. Sustainable computing power can only be achieved with process nodes that are practically available. AI has become the predominant source for demand for computing power, and this trend is driving structural changes in computing systems. Our strategy is to create a new computing architecture and develop computing superpods and superclusters to sustainably meet long-term demand for computing power. So what he's saying there, let's just talk about what he's talking about. Sustainable. Okay, he's talking about having the ability to have sustainable computing power, i.e., how many flops of compute can we get out? But he's also, I believe, the way he said this is that he's also talking about power. Okay, because now, like Larry Ellison, when he gave his talk at his last shareholder meeting, right? When you look at compute power, you can just measure it in watts. It's the same exact thing. Okay, and China has the most secure energy infrastructure in the entire world. And now, when you say that, the U.S.'s energy infrastructure is obviously very secure too, but China is right there. They probably exceed us. They have more nuclear reactors. They're putting in the world's largest hydro dams. They're not looking at any one source being reliant on any one thing. They have diversified it all the way out. And they're, again, like as I previously said, they're producing more of it. He acknowledges what I told you, Chinese mainland will lag behind the semiconductor manufacturing process nodes for a relatively long time. It's going to be about 5 more years before they can catch up on a chip-by-chip basis. Sustainable computing power can only be achieved with process nodes that are practically available. So what he's saying there is, hey, if we're going to have dependence on ourselves here in China, right? The only way we're going to achieve our stuff is to have things that are practically available, i.e., we can't rely on the USA. They might have backdoors. They might have kill switches. They might, on a whim, decide, oh, yeah, we're not going to sell you to H20s. Oh, yeah, we are going to sell you to H20s, but you're going to have a 15% increase because Donald Trump has to take his share out, okay? AI has become the predominant source of demand for computing power, and this trend is driving structural changes in computing systems. Absolutely, absolutely. If you thought that Bitcoin used a lot of energy, then I hate to tell you, but AI uses a lot more. Our strategy is to create a new computing architecture and develops computing superpods and superclusters to sustainably meet long-term demand for computing power. This is acknowledging we are behind on a chip-by-chip basis, but we can network better than everybody else, so we can keep up with the rest of the world through raw brute force, and you don't have to worry because the sustainable power that China is generating is cheaper than the competitors. Okay, so that your cost per watt, your cost per compute is going to be roughly the same. And so that's where I got that 6x number that they brought up before. Even though their largest supercluster is going to outperform the NVL144 by quite a bit more, it's going to use much more energy. But then when you factor in the cheaper energy they have, right, it's still going to outperform. Last year, I wanted to elaborate on that last point, but my team didn't agree. So today, I'd like to take the chance to pick up where I left off. This brings me to the topic of today's keynote, groundbreaking superpod interconnect, leading a new paradigm for AI infrastructure. This theme echoes my 5th point last year, which is about how we've been working to create new computing architecture and develop both computing superpods and superclusters that can sustainably meet long-term demand for computing power. I just want to go on here. Before diving into today's main topic, I'd like to briefly return to the impact that DeepSeek has had on the industry and on Huawei in particular. After DeepSeek went open source, our customers began reaching out to us, pointing out all kinds of issues with the send. This was DeepSeek. DeepSeek reached out to them and they're like, hey, look at these issues that we're having. Okay, we have to use these H20s because we're so deep into CUDA doing this, and we can't do the same thing over you. You need to come up with some kind of compatibility layer or something to help us out here. As well, expressing our hopes for the future. We've been getting suggestions left and right. And then right here, our monetization strategy for AI is focused on hardware. For Khan, we will open interfaces for the compiler and virtual instruction set and fully open source other software. We will go open source and open access with Khan based on existing Ascend 910B, 910C design by December 31st, 2025, and will synchronize the open source and open access plans for future versions with product launch. For our Mind series application enabled kits and toolchains, we will go fully open source by December 31st, 2025. We will also go fully open source on our Open Pangoon foundational models. Okay, so this, I just got to go full screen here. This is absolutely huge. Huawei understands that there's no way that they're going to catch up to Nvidia on their own with CUDA. So what are they doing? They're open sourcing CUDA, but they're looking at it. They're not just going to do it all at once because obviously a lot of it has some proprietary stuff, and they still do compete with other Chinese firms. Okay, they're not idiots. It's not like China has only one company and it's Huawei. They actually have other firms competing with them. So but they said they're pledging by December 31st to have everything open source and Con, right? And also with their Mind Series application development set and toolkit. Okay, and this is tremendous news because what they're saying is they're realizing the power of open source. Okay, they're realizing the power of open source. And right now we're having this backlash in America against open source. Meta went ahead, just calling it Facebook, I always do. Meta went ahead and they open sourced their models for Llama quite some time ago. It was a few years ago when it came out. And I believe that Senator Josh Hawley, don't quote me on that, actually said that, he got mad because it turned out that DeepSeek had used some of these models, right? And he's like, we're letting China use these models. He didn't understand how open source worked. And Mark's like, well, yeah, because it doesn't matter. Anybody can use it. Anybody can improve on it. And then when they do, they have to contribute it back. So it just makes it better for everybody. But of course, America's moving this mindset now that China can't have anything we have. Well, why do we want them to have this? It's just such a simpleton mentality. It benefits nobody. Okay. And we see that China is moving to a model that used to benefit us, right? So you're looking at this country that in America, we're being told is this closed, dark. What did Trump call it? I think one time he called it a dark country, not like dark skin, but like dark, like a dark cloud over the, and it's like, no, I mean, look at this. This is like, if this is what you call a dark cloud, the sky is opening up and the light is coming in. And if you're my fellow American, you got to pay attention to this. Don't believe anything. I don't care if you're watching a left commentator or a right commentator. Do not believe a single word that they say on China, period. Liberal or conservative. Okay. You might say, well, Donald Trump's worse. Well, maybe he is. I don't know. He probably is. He's probably the worst on the topic. But I'm going to tell you, all those liberals out there, they, in a second, like Mehdi Hassan, they would start spouting bad things about China too. Okay. And I like Mehdi Hassan. I like and dislike him. I don't like his stance on China. I think it's a bunch of Western propaganda. But, with Gaza, he's absolutely 100% correct. That's another topic. Okay, so here again, what we're talking about is Huawei is open sourcing this stuff. The reason they're doing that is obviously that's the best way to catch up to Nvidia. Okay, they're going out and they're saying, hey, everybody, come on to here, poke around, submit, pull requests, submit fixes. Let's go ahead and let's make this entire ecosystem better for everybody. Okay. And I think this is intelligent. Google did this with their TensorFlow and look how AI has turned out. Imagine if Google said, no, we're not going to release TensorFlow. We're going to keep it to ourselves. Okay. We may not be at the state that we are right now in AI. Okay. Just to put it like that. Open source is what powers innovation. It powers change. And the fact that China now is becoming a leader in open source and America's getting more closed, it literally blows my mind. And that's not a negative towards China. It would just be that I would hope that America was continuing to be open source leaders and that China was joining us. So it's to see us going the opposite direction. I don't get it. It doesn't make any sense. But cheers to Huawei. They're actually doing the right thing here. Okay, let's move on. Oh, so they're saying that their focus on AI is going to be on hardware, making money on hardware, which is very smart because hardware has high margins. Right now it does. Obviously, it's going to be commoditized in the future. I want to talk about this. Over the next 3 years, we'll be working on 3 new series of Ascend chips, the Ascend 950 series, the Ascend 960 series, and Ascend 970 series. Okay, he talks about that, but we're going to come down here. We're going to talk about the Ascend 950. It's going to be allocating more compute for vector processing, adopting an innovative design that combines SIMD and SIMT. SIMD, which is short for single instruction, multiple data, makes it possible to handle blocks of vectors in a pipeline fashion. SIMT, short for single instruction, multiple threads, supports flexible processing of more fragmented data, and shrinking the granularity of memory access from 512 bytes to 128 bytes. More refined granularity is essential for discrete and discontinuous memory access. So what's he talking about here? You might be, what is all this? So basically with AI, everything is done with these tensors. Tensors are vectors. So basically everything is just wrapped into these into a tensor, and then it's all just computed against each other. Okay, so just think of it as a ton of matrix calculations going on. And so what you want to do is you want to build the best architecture possible to compute this matrix calculation, which is why I say that, Huawei is doing an outstanding job and Nvidia is doing an outstanding job also. But the clear leader in this is Google with their inferencing chip, where literally they took like a hardware representation of a matrix. You might say, what does that even mean? And to tell the truth, I've read it so many times. I've read the paper on it and I still can't explain it. Okay. Only way I can put it is imagine that a matrix was somehow written into a die, and that's what they do. So literally, it doesn't even have a structure set that has to go and say like, I want the next thing in the line. I want the next thing in the pipeline. Like what they're talking about here, there is no pipeline. Everything just automatically flows through the matrix. So it sounds weird. Anyways, I would imagine that Huawei and Nvidia will definitely be looking at that and onto that, but it doesn't matter. Anyways. Third, the Ascend 950 chips will deliver 2 terabytes interconnect bandwidth, which is 2.5 times higher than the Ascend 910Cs. Fourth, different stages of inference have disparate needs for computing power, memory capacity, and memory access bandwidth. The needs of recommendation systems and model training vary too. To address these diverse needs, we will offer 2 proprietary HBMs for the Ascend 950 chips, HIBL 1.0 and HIZQ 2.0. Okay, so I wanted to talk about this. I'm not going to go too deep into this, but this is where they're catching up to Samsung. So Samsung is one of the biggest memory makers right now in the world. This is something that China has lacked, is in the HBM space. Okay. Huawei, obviously this is hardware, so these are going to be proprietary. They're not going to go ahead and release their designs for this, but they're saying they're going to have 2 different versions of this based on your specific needs, which is very smart. Okay. And then the last thing I want to get to in here is where he talks about the what's that we adopted. Oh, and this is important. The chips will support more data formats, including FP32, HF32, FP16, BF16, FP8, MXFP8, HIF8, MXFP4, and HIF4. Now, these are the important ones down here. These are the smaller data types that have come in, especially FP8. It's kind of the standard right now. People are trying to go to FP4, but this is just a floating point 8. What is this? This is just that they take this data, they essentially kind of break it down and assign it to a number, a floating point number, and then they take that number and they put it into a vector, and that's how they train them. They will have higher interconnect bandwidth. The Ascend 950 series will deliver 2 terabytes a second. Ascend 97 series will jump to 4 terabytes a second. Okay, so this is a huge jump over the 910C. This is over twice. I believe this is 3x the interconnect bandwidth of the 910C accelerators. They will deliver more compute too. Obviously, they're going to deliver more compute. Okay. SuperPods have become the main form factor of products for large-scale AI infrastructure. They're becoming the new norm. A SuperPod is a single logical machine made up of multiple physical machines that can learn, think, and reason as one. As computing demands continue to grow, so will SuperPods. Okay, so first we talk about the Atlas 950 SuperPod. It's built with the Ascend 950 DT chips. The SuperPod will have up to 8,192 Ascend 950 DT chips, 20 times more NPUs than our Atlas 900 A3 SuperPod. And its full configurations, man, I'm probably reading a lot to you guys. You guys might be bored. I'm sorry if you're bored. Okay, I really am. I'm looking at this and it's like, I'm really interested in stuff. I'm trying to say it to you, but it is a lot of words that I'm reading. Okay, so basically, because I'm at 30 minutes, I'm going to cut this short right here. I wanted to talk more about this, but I'm kind of like, I don't want to read this whole thing to you. It's a long article. I could literally read every single thing to you. I could talk about it. But I'm at 30 minutes in. Probably no one's still watching, which is absolutely fine. Okay. I know that, I usually just sum this stuff up for you guys, but this is very exciting news. Okay. And let's just interconnect bandwidth will be 16 petabytes a second. Okay. Remember where I was talking about, you have all these chips and they're speaking to each other and they have to have an interconnect speed that makes it like they are a single chip. This is why right here, 16 petabytes a second. Okay, this means a single Atlas 950 SuperPod will have an interconnect bandwidth over 10 times higher than the entire global total peak internet bandwidth. Okay, do you understand that? The entire internet right now on Earth, China, Russia, America, everywhere. Okay, this machine will have a peak internet bandwidth that is 10 times larger than that is than the entire internet bandwidth right now. Okay, that is what allows them to do this. That is what's going to allow them to be comparable. Okay. So anyways, Nvidia plans to launch their NVL144 system in the latter half. I'll read this. Of 2026, our Atlas 950 SuperPod will have 56.8 times more NPUs than they've got GPUs and will deliver 6.7 times more computing power. Our SuperPod will have 15 times more memory capacity, reaching 1,152 terabytes and 16.3 petabytes a second interconnect bandwidth, 62 times higher than its counterpart. And even if we compare it against the NVL 576 system, which is NVL plans to launch in 2027, it's clear that our Atlas 950 SuperPod will still be ahead on all fronts. Okay, guys. So that's what I got for you. Apologies if you made it this far and you're like, what the heck is this guy talking about? I will make videos that are much simpler than this. All this news came out today. It was a lot. I just wanted to get something out to you. But the basic idea is that, and Huawei is being straightforward with it. And you can't lie about it, right? It's not like they're American. They're just going to lie. I'm sorry, I shouldn't say that, but it's just like in our administration, we get lied to every single day. It's all they tell us is lies. And it gets very frustrating. So as an American, I'm extremely frustrated with this stuff, but I shouldn't let my frustrations out on you guys. But they're just being honest with you. So Huawei is being perfectly honest with you and with their own citizens. And they're saying, hey, the simple reality is on a chip or accelerator or whatever you want to call it, GPU to GPU or NPU to NPU, whatever you want to call them. But on a silicon to silicon basis, right? Each individual unit, we're still going to lag behind. Okay. We got to get EUV. It's huge that they got DUV and they're testing it right now, but we still got to get EUV. They even said it's going to take a long time, but it doesn't matter. And here's why. Because we have superior ability to interconnect these, okay? Because we're a networking company and we were the leader in that field. And what we've done here, is we have made a machine that can brute force its way past it. And we don't have to worry about power over here because we have a diverse power supply. We have a sustainable power supply. Nobody's going to threaten our energy sovereignty. Did you notice that Trump, when he made his threats to India about buying Russian gas, he said everybody will face secondary tariffs. He didn't go after China this time. Have you noticed how he's really, rarely targeting China anymore in his talks? Like he did say that about, well, if Europe comes along, then we'll stop the Ukrainian war, but I got to have Europe come along. Okay, because he's afraid to target China now on his own. Okay, because he knows that they'll just blow him off. They're just going to ignore him. Okay, so they're not going to threaten their energy sovereignty. Let it be threatened by America or anybody else. And apparently India isn't either, which I would think is actually pretty smart for anybody that wants to live in a multipolar world. Okay, that's what I got for you guys today. Have a great day. Take care.